Good morning, students. Today we are going to start the Unit 3 continuation topics, that is centroid and center of gravity. The determination of centroids is majorly be classified into three types. Number one, centroids by simple figures. Number two, centroids by composite figures. Number three is by centroids by shaded regions. Let us discuss one by one, and we will do the problems based on centroids of simple figures, centroids of composite figures, and centroids by shaded regions. Let us see this. Centroids by simple figures. Before I am going to explain these centroids by simple figures, let us consider that how many shapes of these simple figures exist. These simple figures are in the following shapes. Number one is L shape. Number two is T shape. Number three is inverted T shape. Number four is I shape. And number five is E shape, etc. We will do some problems on L shape and T shape today. Problem 1. Determine the centroid of the following T section. The given problem diagram is (14 centimeters), 4 centimeters. From here to here is 12 centimeters. And from here to here is 4 centimeters. This was the problem given to us. Now let us see the solution of this problem. The solution of this problem is as follows. The given T section is, now given a problem like this, first of all, we have to divide this shape of T is into how many parts? I will split this T shape into two parts. This is first part and this is second part. Now, we will apply the property of symmetry to this diagram. Let us apply the symmetry property to this T section and the given T section is divided into two parts. When we apply the symmetry property to this diagram, usually the T shape and I shape and inverted T shape are symmetric to y-axis. That means if it is symmetric to y-axis, we need to find x bar. Suppose if it is symmetric to x-axis, we need to find y bar. Now the given T section is symmetric to y-axis. Let us see how it will be. I am drawing the axis to this diagram like this. This is called YY and this is called XX. By looking through this diagram, the given T section is symmetric to y-axis, hence x bar is equal to 0. What is the meaning of this? Let us see this. The given T section is symmetric to y-axis, hence x bar is equal to 0. That means in a centroid, we have two coordinates, x bar and y bar. In this particular diagram, no need to find x bar coordinate, we have to find only y coordinate. So, for the shape of T, and in this particular situation, I would like to explain the shape like T, the shape like inverted T shape, and the shape like I. These three comes under one category that there is no need to find the x bar coordinate because the T shape, inverted T shape, and I shape are symmetric to y-axis, hence no need to find x bar coordinates. So in this particular T section, we need to find only y bar coordinate. Let us see how it will be. To find y bar, in order to find in the given T shape, the given T section is divided into two parts. Part 1 within brackets vertical rectangle part 2 horizontal rectangle. In every part, we need to find areas first of all. The first part, when we look at the diagram, first part is A1 is equal to L into B. For the first part, L is equal to 4 centimeters and B is equal to 12 centimeters. Therefore, A1 is equal to 4 into 12. Therefore, A1 is equal to 48 centimeters square. Suppose if you draw a diagram like this, so that we can get an idea that the given diagram is like this. This is 14 centimeters. We will split into two parts. This portion is 4 centimeters. This portion is 12 centimeters. And this portion is 4 centimeters. So if you look this diagram, the first part is this one. This is called, as I told you, that it is called vertical rectangle. So if you see from here to here, as it is the vertical rectangle, this 4 is considered as length and 12 is considered as breadth. Therefore, I could substitute in place of L is equal to 4 and in place of B, I could substitute 12. Therefore, I could write L into B, that is equal to 4 into 12, which is equal to 48 centimeters square. After finding area with relative to this first part, we need to find the x coordinate and y coordinate. As I told you in the beginning that the given T shape is symmetric to y-axis. Hence, no need to find x bar coordinate. So, x bar is already 0. But to find y bar, we need to find y1 coordinate for the first part. That is like this. Y1 is equal to, we have a stipulated formula that b by 2. This b is called breadth of the first part. So, when you are going to find out area regarding the first part, there I substitute b is nothing but how much? 12. So, I bring that value. So, 12 by 2, that is equal to 6 centimeters. Now, we need to find a1, y1, that is equal, a1 is equal to 48 into y1 is equal to 6 centimeters. That implies 48 into 6, 288 centimeter cube. Similarly, go for the second part. This is called second part. The second part again, the formula for area A2 is equal to L into B. In this, suppose if you are going to find area of the second part, just first part you close like this. So you are seeing only the second part. In the second part is exclusively called horizontal rectangle. Therefore, in this horizontal rectangle, my length is 14 centimeters and my breadth is 4 centimeters. Therefore, I'll bring the value of L here, 14 into 4, that is equal to 56 centimeters square. Similarly, we need to find the y coordinate in this second portion of the horizontal rectangle. How to find x coordinates and y coordinates? So, in this problem, let me tell you the secret of finding x coordinates and y coordinates. Every shape, when you take T shape or L shape or I shape, when you are going to find out the x bar and y bar coordinates, for all x coordinates, say x1, x2, x3, so on, we should move from left to right direction. That is one of the first formula you have to remember. For calculating all x coordinates, we move from left to right. And for finding y coordinates, we move from downwards to upward direction. Downwards to upward direction. So therefore, here in this case, y1 is equal to, again, b plus b by 2. We have a stipulated formula to find y2, that is equal to b plus b by 2. This b is belonging to the first portion of the rectangle. First portion of the rectangle is vertical rectangle. So in first portion of the vertical rectangle, my b is equal to how much? 12. So I could add 12 plus, and this b belongs to the second portion of the breadth. Second portion of the horizontal rectangle breadth is 4 centimeters. So therefore I could substitute like this. B is equal to how much? 4. 4 by 2. That implies y2 is equal to 12 plus 2. That is equal to 14 centimeters. And as we need to find A2, Y2. Therefore, A2, Y2 is equal to 56 into 14. That implies, if we will calculate this by using calculator, we will get 784 centimeter cube. Now, y bar is equal to A1, Y1 plus A2, Y2 by A1 plus A2. We have already calculated A1, Y1, A2, Y2. Bring these two values and substitute in the above formula. We will get 288 plus 784 divided by A1 48 plus A2. A2 is 56. Therefore, y bar is equal to 10.3 centimeters. This is the y coordinate of the given T section. Therefore, centroid of the given T section can be written as, for final conclusion of this problem is, centroid of the given T section is, you could write like this, C of x bar comma y bar is equal to C of 0 comma 10.3 centimeters. This is the ultimate answer of this particular given problem. Centroid of the given T section is C of x bar comma y bar, that is equal to C of 0 comma 10.3 centimeters. Problem 2. determine the centroid of the following L section. Let me draw this, the given problem. I am drawing the diagram. This is 3 centimeters. This is 3 centimeters. Six centimeters, and this is 10 centimeters. This was the problem given. Now, solution of this problem. First of all, the given T section or the given L section, whether it is symmetric to x-axis or y-axis, we need to find. As I told you in the previous problem, only I section, T section and inverted T section, these three are symmetric to y-axis, hence x bar coordinate is equal to 0. But for L section, which is not symmetric to any of the axes, so that we have to write it in the first form. Therefore, the given T section, the given L section, is not symmetric to any of the axes, hence we need to find both x bar and y bar. The given L section is divided into two parts like this. I am splitting into the two parts. This is first part, this is second part. The given L section solution. The given L section is divided into two parts. Part 1, Part 2. Part 1 is horizontal rectangle. In this, my L is equal to 6 centimeters and my B is equal to 3 centimeters. So therefore, A1 is equal to L into B. That implies 6 into 3 is equal to 18 centimeters square. Now we need to find x coordinates also. For the first portion of this horizontal rectangle, x1 is equal to, we have a specific formula that x1 is equal to L by 2. In the previous problem, I told you that to find all x coordinates, we move from left to right. So therefore, if you take the first portion, we need to have a formula x1 is equal to L by 2. So to find the area of this first portion, we use L as 6 centimeters. So bring that value and substitute it there. X1 is equal to L by 2, that is equal to 6 by 2, which is equal to 3 centimeters. Similarly, Y1 is equal to B by 2. That implies for the first portion, my B is how much? I should calculate y coordinates. I should move from downward to upward direction. That is the secret of finding y coordinates. So if you take first portion, before this portion, we don't have anything else. Therefore, for this portion, my B is considered as 3. That itself is the value of 3. That implies y1 is equal to B, which is equal to 3 by 2. That is equal to 1.5 centimeters. Now, using this A1, X1, Y1, we need to find A1, X1, A1, Y1. Let us see. A1, X1 is equal to 18 into 3 is equal to 54 centimeter cube, and A1, Y1 is equal to 18 into Y1 to 1.5, which is equal to 27 centimeter cube. For the part 2, A2 is equal to L into B. This is vertical rectangle. So in the vertical rectangle, if you draw the diagram so that you get an idea to do the problem, a rough diagram like this. This is called first part, this is called second part, and from here to here is 10 centimeters. And from here to here is 6 centimeters. This is 3 centimeters. This is also 3 centimeters. If you split this L section into two parts, from here to here is, you have to find, actually from here to here is 10. So if you remove these 3 centimeters from 10 centimeters, you will get from here to here is only 7 centimeters. So that we can consider it as L here. Okay. Therefore, A2 is equal to L here is nothing but 7 into B. How much? 3. Therefore, A2 is equal to 21 centimeter square. Then we need to find the x2 coordinate for the second portion. As I told you, for all x coordinates, whether it is x1, x2 or x3, we will move from left to direction, left direction to right direction. So therefore, to find x2, we have a formula that is equal to L plus L by 2. Number by x2 is equal to, this L becomes 0 because before this portion, we don't have any other L's. Therefore, this L is equal to 0. First L is equal to 0 plus, and the second L is the portion of the second one. Therefore, my L is how much here? What L I used here, that only I'll substitute here to find area. So my L is 7 centimeters. Bring it and substitute it there. X2 is equal to 0 plus 3.5. Therefore, X2 is equal to 3.5 centimeters. Similarly, we need to find for the second portion Y2 coordinate. Y2 is equal to B plus B by 2. For finding Y coordinate for the second portion is attaching with first portion of the first rectangle. Therefore, this B belongs to first portion of the rectangle. That is how much it is? 3. So that means we are going to find Y coordinates. We should move from downward to upward direction. My second portion is attaching with first portion. So I need to find the Y coordinate for this is B plus second portion is B. So this B belongs to first portion. This B belongs to second portion. Therefore, this B is equal to how much? 3. Therefore, 3 plus this B belongs to second portion. So, here B we used how much? 3. Therefore, 3 by 2. That is equal to 3 plus 3 by 2 means 1.5. That implies Y2 is equal to 4.5 centimeters. Using X2 and Y2, we need to find A2X2 and A2Y2. That we will see. Therefore, A2X2 is equal to 21 into 1.5. That implies 31.5 centimeter cube. And A2Y2 is equal to 21 into 4.5. 94.5. To find X bar and Y bar. X bar is equal to, we have a specific formula, A1X1 plus A2X2 by A1 plus A2. That implies A1X1 is equal to how much? 54 plus A2X2 is how much? 31.5 divided by A1 is equal to 18 plus 21. That implies adding both of them, we will get 85.5 by 39, which is equal to approximately 2.19 centimeters. Therefore, X bar is equal to 2.19 centimeters. And similarly, Y bar is equal to A1Y1 plus A2Y2 divided by A1 plus A2. Therefore, Y bar is equal to A1Y1 is equal to 31.5 plus A2Y2 is equal to 94.5 divided by A1 plus A2. That means 18 plus 21, which is equal to 126.0 divided by 39. 4.19 centimeters. This is Y coordinate. Therefore, X coordinate is equal to, X bar is equal to 2.19 centimeters and Y bar is equal to 4.19 centimeters. Therefore, the centroid of the given L section is C of x bar comma y bar is equal to C of 2.19 comma 4.19 centimeters. This is the ultimate answer of the given problem. Therefore, the centroid of the given intersection is C of x bar comma y bar is equal to C of 2.19 comma 4.19 centimeters. Now let us discuss the centroid of the shapes of some simple figures. The second parameter is determination of centroids by composite figures. This is the second category. The first category is determination of centroids by simple figures, and the second category is determination of centroids by composite figures. To find the determination of centroid by composite figures, we have a specific formulas for simple figures. Let us see this. Centroids and their formulas of some standard figures. We will classify this board into like this. Number one, serial number, name of the shape, name of shape of specimen, diagram, x bar, the coordinate of x bar, the coordinate of y bar, and area. So let us like this. The first one is rectangle. The diagram of rectangle is like this. Take x-axis, y-axis. This is centroid. X bar is L by 2, y bar is B by 2, and area is L into B. That is the first portion. Next, second one. If you split this into like this. The second one is triangle. X-axis, y-axis, there the centroid. The formula for x bar is B by 2, H by 3, and 1 by 2 BH. This is the second specimen. So the first specimen is rectangle. The shape will be drawn in xy plane is like this. And the x coordinate of rectangle is L by 2. Y coordinate of rectangle is B by 2. Area of rectangle is L into B. Similarly, go for second shape, triangle. The triangle will be drawn like this. In xy plane, the triangle will be drawn like this. Imagine that this is called B, which is called base. And what is this H? So the x coordinate of triangle is B by 2. Y coordinate of triangle is H by 3. And the area of triangle is 1 by 2 BH. This is the second diagram. Similarly, the third specimen is a right angle triangle. That we will draw like this. X-axis, y-axis, and this is right angle triangle. This is called centroid. Imagine that this is base of the triangle and this is height of the triangle. So the formula for x coordinate is B by 3, H by 3, and area is 1 by 2 BH. We have to remember these formulas. Fourth specimen is circle that I will draw like this, xy, y-axis, and my circle will be represented by like this. This is center point, and from here to here is called D, that is diameter, and from here to here is also considered as D, that is called diameter. So the x coordinate of circle is d by 2, y coordinate of circle is also d by 2, and the area of circle is pi r square. So therefore, if you see these two shapes of the diagrams, third shape is right angle triangle. It will be drawn like this. So x coordinate of right angle triangle is b by 3, y coordinate of right angle triangle is h by 3, and the area of right angle triangle is 1 by 2bh. Similarly, for the fourth specimen, circle, x coordinate of circle is d by 2, y coordinate of circle is d by 2, and the area of circle is pi r square. Okay. Then next we will have one more two diagrams, which is known as, the fifth specimen is semicircle. It will be drawn like this. Take x-axis, y-axis, and this is called semicircle. Here we have centroid. This is diameter, and from here to here is radius r. So the x coordinate is d by 2, y coordinate is 4r by 3 point, and the area of semicircle is, we know that, pi r square by 2. The last and final specimen, namely quarter circle. This can be represented by like this. Again, take x-axis, y-axis, and this is called quarter circle. The center point of this quarter circle is represented by like this. From here to here is radius. From here to here is radius. The x coordinate of quarter circle is 4r by 3 pi. And the y coordinate of quarter circle is again 4r by 3 pi, and the area of quarter circle is pi r square by 4. Let us see once here. So the last two specimens followed by standard figures. Fifth specimen is semicircle. X coordinate of semicircle is d by 2, y coordinate of semicircle is 4r by 3 pi, area of semicircle is pi r square by 2. Similarly, sixth specimen is quarter circle. X coordinate of quarter circle is 4r by 3 pi, y coordinate of quarter circle is 4r by 3 pi, and the area of quarter circle is pi r square by 4. Next, we will go for determination of centroids by composite figures. We will do one problem on this. Determine problem 3. Determine the centroid of the following composite figure. This was the diagram given to us. So, if you see this diagram, strictly speaking, that it is a composite figure. It does not come under simple figure. In simple figures, the only one secret is we have either rectangle horizontal rectangles or vertical rectangles. So let us see the solution of this problem. To find the centroid of this composite figure, first we will apply the symmetry property to this problem. So let us apply the symmetry property, that is like this. XX YY. See, if you see this diagram, my dear students, strictly speaking that the given composite figure is not symmetric to any of the axes. Therefore, we need to find both the x bar coordinate and y bar coordinates. Let us see this. Solution. The given composite figure is not symmetric to any of the axes. Hence, we need to find both x bar and y bar coordinates. For our convenience, this composite figure is divided into three parts. That will be like this. This is first part, this is second part, and this is third part. So strictly speaking that first part is semicircle in the shape, second part is rectangle, third part is triangle. Let us see the solution of this. The given composite figure is divided into three parts. First part, part 1, semicircle. In the part 1, we have given radius r is equal to 2.5 centimeters. So to find area, we have a formula that A1 is equal to pi r square by 2. That implies A1 is equal to 3.14 into 2.5 whole square divided by 2. Therefore, A1 is equal to, after simplifying this with calculator, we will get 9.81 centimeter square. Then we need to find the x coordinate and y coordinate to the semicircle. Let us see how it will be. For calculating x1, we have a standard formula that r minus 4r by 3 pi. This is a formula to find the x1 coordinate. That implies, as we know that r is equal to 2.5, 2.5 minus 4 into 2.5 divided by 3 into 3.14. Calculator is very much important to do all these problems. 2.5 minus 4 into 2.5 by 3 into 3.14. After simplifying this, we will get 1.44 centimeters. This is x1 coordinate. Similarly, y1, as I told you in the previous problem that for calculating all x coordinates, we will move from left to right, and for all y coordinates, we will move from down to upward direction. So, for the if you see the diagram, y1 is equal to, we have a formula that b by 2. Here, y1 is equal to radius, as it is, as our shape of the circle is semicircle. Therefore, y1 is equal to r. My radius itself is nothing but y coordinate. Therefore, y1 is equal to r, that is equal to 2.5 centimeters. Now, using this a1, x1 and y1, we need to find a1 x1, that is equal to 9.81 into x1 is 1.44, that is equal to 14.12 centimeter cube. Similarly, a1 y1 is equal to, a1 is equal to 9.81 into y1 is equal to 2.5, that 24.5 0.52 centimeter cube. Okay, so this is the value of finding A1x1, A1y1. A1x1, A1y1, they both are related to the first part, as we already considered that first part is called semicircle. Okay, similarly we will go for part 2. Part 2 is a rectangle. A2 is equal to L into B, area. So if you see the diagram, A2 is equal to, L is equal to 16.5 into B, 5. Therefore, A2 is equal to, after simplifying with this calculator, 82.5 centimeter square. So in this rectangle, my coordinate, my x coordinate is x2 and my y coordinate is y2. Therefore, x2 is equal to formula L plus L by 2. Therefore, x2 is equal to, this L belongs to first part. As I told you that all x coordinates moves from left to right direction. Therefore, here L is equal to nothing but radius. Therefore, 2.5 plus L, that is how much? 16.5 by 2. Therefore, my x2 is equal to, after simplifying this, we will get 10.75 centimeters. This is the value of x2. Similarly, y2 is equal to b plus b by 2. In this particular y2 coordinate, we don't have a previous shape to this b. Therefore, this b becomes how much? 0. Therefore, b is equal to 0 as there is no previous other shape, and this b belongs to rectangle, that is how much? 5 by 2. That implies 2.5 centimeters. Now, using this x2 and y2, we need to find a2x2, a2y2. That implies. Therefore, a2x2 is equal to 82.5, x2 is equal to into 10.75. After simplifying this with calculator, we will get 886.87 centimeter cube. Similarly, A2Y2 is equal to 82.5 into Y2. Y2 is how much? 2.5. So after simplifying this with calculator, you will get 206.25 centimeter cube. These are the values of A2x2, A2y2 by using the part 2, that is rectangle. Similarly, we have to find for part 3. Let us see this. Part 3, triangle. Area A3 is equal to 1 by 2 BH. That implies 1 by 2 into, if you see the diagram, my breadth is equal to 8.5 into H4. 2 times, I will get 8.5 into 2, we will get 17 centimeter square. Similarly, for the third part also, we need to find x3. So, x3 is equal to, we have a formula, L plus L by 2. This L belongs to first portion, this L belongs to second portion, and this L belongs to third portion. That is what? Triangle. So, let us see this. This portion is nothing but radius, that is 2.5. So, 2.5 plus this L belongs to second portion, that is rectangle. In rectangle, my L is equal to how much? 8 centimeters. Therefore, 8 plus third portion L is equal to how much? Nothing but L means here B, 8.5 by 2. That is equal to 14.75 centimeters. Similarly, we need to find Y3. Y3 is equal to, we have a formula B plus B by 2. That implies for the first portion B 0 and for the second portion we have B. So for the first portion 0 and for the second portion, as we move from down to upward direction, this B belongs to second specimen, that is rectangle. How much it is? 5 plus this B belongs to again third portion. What is my B here? 8.5. That implies 8.5 by 3. That implies after simplifying this, we will get 6.33 centimeters. This is y3. So you got the value of x3, you got the value of y3. Using x3, y3, we need to find a3, x3 and a3, y3. Therefore, a3, x3 is equals 17 into x3, 14.75. After simplifying this with calculator, we have 250.75 centimeter cube. Similarly, a3, y3 is equals 17 into, what is y3? 6.33. 6.33. That implies, after simplifying with this, we get 107.61 centimeter cube. So therefore, this is a3x3, a3y3 related to the part 3. What is part 3 here? Triangle. That means in a composite figure, is the combination of semicircle with rectangle with triangle. Like that, we will have many number of models. Okay, now using a1x1, a2x2, a3x3, we will find x bar. Using a1y1, a2y2 and a3y3, we will find y bar. Let us see this. Therefore, x bar is equals a1x1 plus a2x2 plus a3x3 divided by a1 plus a2 plus a3. That implies, therefore, x bar is equal to a1x1 plus a2x2 plus a3x3 by a1 plus a2 plus a3. Therefore, x bar is equal to, bring the value of a1x1, that is 14.12, a2x3 is 86.87 plus a3x3 is 250.75 divided by a1 plus a2 plus a3, that is 9.81 plus 82.5 plus 17. And after simplifying this, we will get x bar is equal to 10.5 centimeters. And similarly, y bar is equal to a1y1 plus a2y2 plus a3y3 whole divided by a1 plus a2 plus a3. Bring the values of a1y1, a2y2, a3y3 and respective places we substitute. We will get 24.52 plus 206.25 plus a3y3 107.61 whole by a1 is 9.81, a2 is 82.5, a3 is 17. After simplifying, we will get y bar is equal to 3.09 centimeters. So, the centroid of the given composite figure can be written as conclusion. The centroid of given composite figure is C of x bar comma y bar is equal to C of 10.5 comma y bar 3.09 centimeters. This is the ultimate answer of this problem. So the centroid of the given composite figure is C of x bar comma y bar is equal to C of 10.5 comma 3.09 centimeters. This is what is known as the how to do the problem on composite figures. So therefore, as I told you in the beginning, that determination of centroids are majorly be classified into three types. One is simple figures, second one is composite figures, and we left one more which is called determination of centroid by shaded regions that we will see in the next class. Thank you very much. Okay.